anyways, yeah. So
Mm.
yeah, feel free to get started.
Yeah. All right. Welcome everyone to our first meeting for the graphic programming night. Um, we are very excited to have you all here and provide you with information about the club. Um, this meeting will basically be about information and the workshop afterwards. So we recommend that you stay for the amazing slides that we have at the end. With that, what is JPK? Um, so. Wait, besides, oh yeah. What is JPK? Basically, this is a student-run organization that, um, whether you are a beginner or an expert or an experienced programming, uh, we want you to be interested in graphic programming, which, um, in it has many realms really, with like shaders and physics and math, which I think is very cool. I think you guys can be like really excited about that. Uh, but I think the main thing to get out of here is to have a fun time with computer graphics. But with that, let's meet our officers, which here's the board, and everybody will introduce themselves, starting with our president, Alex.
Okay, yeah. My name is Alex. I'm the president. And then this is just for the other officers, but we're kind of just going to introduce ourselves. So, major, year, interests, and like a fun fact. So, I'm a computer science major. I'm a junior now. My interests, like academically, are like software development, game development, like extended reality, and graphics is a lot of fun. And then a fun fact about me, I play trumpet and I like to snowboard. Okay,
Mm.
Alejandro.
Er, all right, so I'm Alejandro. I'm a second year here at UCF. I'm studying comp sci. Um, a big thing that you will see me talk about is making games. Like talking about soccer. So you will see me a lot. You can hear me talk a lot. But a fun fact about me is that my favorite video game is A Hat in Time, which I recommend to everyone to play at least once. It's a great game. But yeah, next officer.
Hello, yeah. So I'm Sebastian. I'm the secretary. I'm a second year computer science major here at UCF. My interests mainly rely on gaming and that sort of field, um, or in academically, more towards like the software engineering, like the data science, machine learning side. Um, as far as a fun fact, I just built a new gaming PC. So if anyone's interested in PC parts, I know there's a club for that as well. But yeah, if you want to talk about PCs, then I'm your guy.
Hi guys, I'm Aiden. I'm a junior in CS. My main interest is also game dev and technical art. And a fun fact about me is that I have over 2,000 hours in Sims 3. Right.
That's a lot of hours.
Yes.
Hello, everyone. My name is Eric. I'm the outreach lead. I'm majoring in computer science. I'm a second year. My main interests right
Oh,
now are game development.
Eric.
What?
Eric.
Yeah, but it's mainly game design and web development right now. I'm working a lot on Unreal Engine. I'm learning C++ right now. It's a lot of fun. So if you're interested in that, you could always shoot me a DM and stuff. Fun fact about me: I just posted her in pets pictures in the pets channel. I have a cat named Porky. She's very fat, but I love her very much. But she's also very cute. So if you want to see an awesome cat, you can look in the pets pictures. She's a goat, bro.
Hey, hello everyone. I'm Luciana. I'm a computer science major. I'm on my third year. I'm also interested in the video game industry. And a fun fact about me is that I have a dog that is an attention seeker. So if you hear him on the back, I'm so sorry. And another fun fact about me is that I like a lot of things that aren't related to my career, such as knitting, skateboarding, and making ceramic or clay figures.
Okay, so back to
Yeah.
Alejandro, I think.
Yeah.
Yeah.
Yeah. Yeah. So, what cool things do we have planned? You may be asking that. So, we plan to bring industry speakers, workshops, team project, but like going into them, we plan to have workshops for everyone to learn to experience something in computer graphics, something that they are interested on. And for industry speakers, we want to get professionals in the industry. We want to get everyone to like get someone that they may respect um, in the field that we all want to progress on, like learn about. Another thing that we have planned is a team project, which I think is pretty cool. It's sort of like a hackathon or a game jam if you have heard of those things, but basically what they are is that they build a specific program. And for computer graphics, we will make like shaders or something like that, or like engines of that style. And yeah, um, anything else um, we want you to get experience on everything, basically. And with that, I encourage everyone to hear and make a workshop with us to collaborate with us. I think that would be pretty great. Wait, uh, Alex, can
Uh,
my synthesis
yeah,
slide?
yeah.
Yeah,
Oops.
yeah. So basically, we have a form coming soon to get people that are interested in working out with us with a workshop, and we will have it really soon to people that are interested, and plan with other clubs here at UCF to get something that works for both of us. And please message an officer. But yeah, with that, remember to follow our socials. We have the link tree over here in the QR code, and follow us on Instagram and YouTube and anything else that we have. I think we have, yeah, we have a LinkedIn.
Yeah, we
Um,
have LinkedIn.
so please follow us on everything that we have on this link tree. We'll have like 1 minute so like you can scan it. Actually, we'll probably post these slides on announcements later. But yeah, I think that's it for the GBM, and now we are starting on the workshop with Alex. So now he can take it away.
Thank you for that first part. It was good. All right, guys. So today we're gonna learn a little bit about shader programming. So this is very intro level. You guys don't have to know much at all. It's good if you have a little bit of programming experience, but even that, this should be pretty comprehensive. So, oh yeah, and this was made with a shader, most of it. Um, all right, so you can make stuff like that. So, what we'll be using today, shadertoy.com. It's a very simple tool. Oh, thank you. Yes, that's a good link right there. That'll bring you to a brand new project. It's a simple web-based tool for GLSL shader programming. All right, so what is a shader? Basically, a shader is a GPU program that runs on GPU hardware. So why is that different than any of the regular programs that we write in our favorite languages? So unlike traditional code that we typically write for the CPU, shaders have like special constraints and quirks to them that make programming them like weird and different. But they are not magic. They are not magic. So we will see how that all works soon. So what do people use shaders for? Typically, when you think of like shaders, you're either between vertex or fragment slash pixel shaders. Vertex. So and this is like in the process. This is like in the context of the like graphics pipeline in like your like you know video games and stuff like this. So vertex shaders typically do operations on your geometry. So that's like your 3D models, your meshes, whatever you want to call them. And then that data gets passed on to fragment shaders. And what those do is they perform operations for, you could think of it as like an operation for every pixel on your screen. And they like give you a color for your pixels. That's like a simplified version of it. And then there's also compute shaders, and there's other ones too. They're mostly just naming conventions, but with shaders, you can kind of compute a lot of things. There's a lot of problems you can solve with them, and they're very very cool. Uh, so why shaders? So why even use shaders? You know, we have this great good old traditional code, but why would we want to use shaders to solve like problems that were like on the previous slide? So this you guys can see my cursor. These two images kind of simplify the like way that input and output happens for CPU versus GPU. So this analogy right here that I'm about to explain comes from a great resource called the Book of Shaders. If you can link that, it'll be in the slides. If you can link that, somebody in the chat, Book of Shaders, chapter 1, or just Book of Shaders. So the analogy you can kind of read this. I took it from there. So we can imagine our CPU as this big industrial pipe that takes that handles things that we pass into it. So in this analogy, our this pipe is a thread, what we would call a thread on the CPU. And this large pipe is great for making like really complex problems, but the issue is that we can only make one at a time. So we have to wait for the last thing to be done before we can make a new thing. So what if we wanted to make a bunch of small, simple products all at once? So this is literally what the GPU is doing. So we can compute a bunch of tiny tasks in parallel. So we won't go too much into depth on how GPUs work under the hood because that's even beyond me. But just know that the strength of GPUs is computing smaller tasks in parallel. So from a rendering point of view, because again, renderings are kind of our main goal here. Imagine your 1920 by 1080 screen full of pixels, right? That's I have the number here, 2,073,600 pixels that we need to calculate. So putting each one of those pixels in through the CPU would take a long time. And there's not that much stuff we need to do per pixel for simpler stuff, right? So we can use the GPU here to calculate each pixel all at the same time. And then once we have all that information, we render it. So yeah, that's like a simplified explanation of how the GPU versus CPU works. But the issue with shader programs is there's limitations. So the basic limitations. So for every so in order for things to run in parallel, right? That's the whole point of this. Every thread must be independent of every other thread. So what that means is that you can't like check the result of another thread on the same like draw call. So you can't like say if I have a value that's happening in one thread, I can't check that in another thread. There's no intercommunication. And then another limitation is that threads don't have memory inherently. So like something that happened on a previous draw, I'll say easily see it without doing stuff and passing things through the CPU back into the GPU for the next draw call. And the reason for this is the GPU keeps its threads constantly busy, so we can't like predict when like the last thing was done. So because it immediately goes onto the next data process. Um, so yeah, that's a little bit about that. All right, so this is a simple example of a shader toy GLSL little code snippet and output result here. So some of the things I'd like to go over are kind of like what GLSL looks like. So GLSL, it's a C-like language. So if you guys have ever done like Intro to C, it's very similar to that. There's a single main function that is like run, similar to C. There's built-in variables, types, and functions. So for variables, we have things like they're predefined things like well in we don't actually have to call them frag color and frag chord, but in shader toy we have I'll explain kind of what like qualifiers are, but it's these in and out keywords here. And they basically serve as like input output for your program, for the process actually. So and then we have types like vec2, vec3, vec4. You can kind of see some on the screen here. And then you have functions. For accessing these vectors, so like this is a lot of syntax stuff, right? So for accessing these vectors, this is like, for example, our UV here, that's just a variable name, so don't worry too much about that right now. But we can access we can like, this is basically returning us a vec2 here, uv.xy, that contains the x and y components like to the respective like component. So and then there's swizzling, which is again like using these like accessors, but changing the order of like what we're doing. So we could do something like uv.yz, and I will show you a quick thing here. So this is the same, I think the same program that we had up there. It should be good enough to view. So okay, we'll look at swizzling real quick. So oh actually, okay, so we have predefined variables, right? In shader toy specifically, there's a few ones. It changes. Shader toy is a little special than like regular GLSL using like OpenGL as your like CPU management, context management system. But so we have things like eye resolution, which is basically a global variable that gives us the screen resolution. We have all these other ones here too. I think there's more that are hidden, but a bunch of useful stuff that we can use for shader toy specifically. Yes, I'm using that site. So like say that I want, so don't worry too much yet about what's going on in the screen, but say that I wanted to like change this vec3 to have, for its first two components to be the y and z, or actually we'll just switch y and x. You'll see that so this color is going into our output, but we'll see that the color is kind of flipped here. This is actually a really like common representation of how UV coordinates work on like kind of like by using the colors. And actually, I'll go into that right now. So UV is kind of like UV coordinates are a very common thing with like textures and stuff like that, and they're just a way of mapping like pieces of a texture or something to like a normalized, well, typically normalized, or some sort of like bounded region. So our UV coordinates are in the range of sort of, I'll say sort of 0 to 1, just because things can change. And actually, no, they are here 0 to 1. You'll see later it won't really be 0 to 1 because this is we'll do some stuff with fixing the aspect ratio. So this is like in a 0 to 1 range, and so kind of what's going on here. This might be a bit of a flashbang, but you can see that actually we'll go back to this one. You can see that there's a bunch of red down here, a bunch of green up here, and then kind of yellow. So we're passing in, for this color value, we're passing in UV XY and 0, as 0 is the third component. So 0 is, so okay, I guess I should have explained this earlier. These vec3s and vec4s can also represent colors. They don't have to represent positions and on screen space. So they can represent anything you wanted to, really. And even another way we could do this is accessing using like those like different letters. But so anyways, but our red channel is mapped to uv.x, and our yellow or no, our green channel is mapped to uv.y. So you can see down here, this pixel down here, this one I'm pointing to, this arbitrary pixel, is a UV of like 110 or something, right? So that's completely red. Same here is 0, 1, and then up here would be something like 1, 1, and so you can kind of see how we're mapping these UV coordinates out based on the fragment chord. This fragment chord, by the way, and the reason we're dividing by resolution is this is just the raw 0 to like resolution of whatever this screen is. So this is like a 1080p monitor, I think. So this is like 0 to 1080, I guess, up here. So yeah, all right. So that's this kind of the basics. Oh, we need to show the slides. All right, so there's a lot of cool functions for GLSL. Here are some of them. I won't spend, no, I'll spend some time on some of them. So we have length here. This X, don't worry too much about the type. It's actually, the documentation specifies it's a generic type. So there's like a bunch of different ways that, I don't know if GLSL actually has like templated code or generics or anything like that, but it, it can handle like pretty much any type. And it returns a scalar length from that given vector. So you can pass in any sort of vector in there. Step, you can kind of think of it as a as an if else that returns 1 or 0, but it literally just says if the x if the value you're passing in here is less than edge, and these two values have to be, I don't know if they have to be scalar, but they do have to be the same type. You return 0, else you return 1. So so mix, that's a way, that's just their linear interpolation function. So you take two values and then well, typically you want to keep it bounded between 0 and 1 for the math to work properly. But you take a like interpolator value, and so if I put 0 into here, this would return x, and if I put 1 into here, this would return y, and something in between it would return the linearly interpolated value between these two. Fract we won't use in this demo, but it's cool to know. It's the fractional part of x. So the next we have smooth step. This is a fun one. I can show you guys a graph in a second. It's this one, but it's similar to step, but it has this lower and upper bound. So step just had one thing and it would kind of cut off. So it would be like, imagine that it would just be 0 all the way here, and then it would just straight jump to 1. So smooth step does have that. So anything less than edge 0 returns 0. Anything greater than edge 1 returns 1. And then but if x is between these two, it smoothly interpolates between edge 0 and edge 1, or between 0 and 1. So I can, and then sine and cosine, and GLSL takes in radians. That's the only reason I wanted to put that up there. But this is like a little Desmos example of what smooth step kind of looks like. So you can see as we move, A and B are edge 1 and edge 0 and edge 1 here. So you can see it'll either ramp up to 0. This is basically step. If we put these really close together, this is essentially what step does. And smooth step just makes it smooth between 0 and 1. So pretty cool. Shaping functions. I won't go into these too much. Oh, actually, thank you for putting that there. I want to quickly like just glance at them. But shaping functions, let me actually go back to the slides. So kind of like we want to create cool visuals with these shaders, like these fragment shaders. So sometimes you have to like be able to shape your inputs. So whether that be UV cores, your like sampled texture, or noise, or whatever, you want to turn that by either like blending it, clipping it, doing something with the values to turn it into something else. You can use like shaping functions. And my goat, Inigo Quiles, he is like the master of shader programming. He has a really cool website with tons and tons of articles, but you can see some of his shaping functions that he's written out for us nicely. that help us. They're usually bounded in the 0 to 1 range because in shader programming, having bounded ranges are very nice. They're just easy to work with. So, but anyways, so we have lots of cool shaping functions, and you can do a lot of interesting stuff with this. The GPK logo had a bunch of shaping functions going into it. All right. All right, so we're gonna get your typing fingers ready, get your thinking caps on, because we're gonna we're gonna code a shader. So oh wait, let me not look at that yet. So first shader we're gonna do. So the code is up here. You guys can copy it if you want. So right now it is black. So I'm gonna explain what's going on here in a second. This is sort of what was going on in the first one, but more. There's some other stuff going on here. So right now we're saying UV, and we're just setting it to our fragment chords. So that's 0, 0 down here, and then it's resolution value up here. Now here we're multiplying it by 2. You'll see why this is important later. So now the range is basically doubled. Here we're subtracting it, so we're actually going to offset it. So now you see we multiplied it by 2, and now we're our the center position of our screen is between negative I resolution and I resolution. So 0, 0 is actually right here in the middle. And then the next thing we're going to do is, so notice on this one, we divided by xy. Here we're actually just going to divide by y. And the reason we're doing that is so you see how this panel I have here, this viewport, is a rectangle. If we divide both x and y coordinates by y, so by the way, we're dividing a vector 2 by a scalar. So it divides both coordinates by the scalar. If our screen is square, we get this negative 1 to 1 range. If our screen's rectangle, it's almost like having this 1 to 1 range within our rectangle, and then having like extra that's just like not really in our thoughts. So you could say it like that, but it basically means that every x value is proportionate to every y value. It is like, yeah, is exactly proportional to the other. It's square. All right, so then moving on. So we're gonna say, okay, vec3 color. We're just saying, setting our color. And the first thing we're gonna do here, this is gonna look almost like the first one. You can see 0, 0 is in our middle now. So we have all this black here that's negative, literally. And then we have kind of what we had earlier with the yellow and green and whatever. So the next thing we're doing is we're setting this t value, and all this t value, don't worry about the names too much, but this is one of our predefined like global variables. It just gives us time. It's basically this time down here, and we're throwing it to sine, so we don't really care if it's in radians or not because I'm not too worried about it. And then we're gonna throw an absolute value sign on it, and then we're gonna set the entire color. So we're saying vec3 t, that sets every coordinate or every component of this vec3 to the value t. So if you guys have any guesses as to what's going to go on here, well, keep them to yourselves, but I'm going to show you. Yeah, we're oscillating between fully black, so 0 and 1. So you can pretty much expect that to behave exactly like this. But that's not very cool. We don't want colors. So the next thing we're going to do is have our C value, which is like a color, literally. And we're going to use this T value as, so remember our mix function. We're going to use this T value as our interpolator value because it is in a 0 to 1 range now because we throw it into sine, which is negative 1 to 1, and then we absolutely valued it. So now we have the 0 to 1 range value, and we're going to interpolate between these two colors. So this is red and green. And now we're setting color equal to that, and then we're going to return it. So we can see what that does, and it literally just switches between green and red. So pretty simple, pretty cool. And this is the code that we just looked at. All right, so another cool tool that people have figured out, the mathematicians, is our sign distance functions. And it's a simple concept, but they can be extended to do a lot of really cool stuff, and they're very useful for shaders um, because of shader programs restrictions. So SDFs are used to represent shapes. So they take in a position in space, or like for example our screen space, and they return a value representing if that position is inside. It's a scalar, representing if it's inside or outside that shape. So values inside the shape are negative, and values outside of the shape are positive, and values right on the line are 0. So these two like examples here are more complicated SDFs that we're not going to use right now. Inigo Quiles, he figured out the math behind these. You can look at the dist functions 2D link there. And yeah, they're very cool for making shapes. You can do a lot of constructive geometry with them as well. So say I like defined two SDFs and then I use that mix function. I mixed between them and then outputted that. We would get something that like blended the two of them, and it's very cool. Or like merged the two of them. So now we're going to use SDF. So onto our next one. So again, we're starting with black. This is the same code as before. This is just condensed into one line. All right, so we're going to be using a circle. So in order to create a circle, first of all, this first line is very important because we want 0, 0 to be, so I don't want to deal with offsetting our circle. So we want to just put our circle in the origin. So 0, 0 is going to be in the middle of our screen right now because of how we set these UV chords. And then that's the position that we're going to sample. So this little line here, this is the SDF for a circle. So length, that's the basically the magnitude of UV dot xy. So for example, zero. So when UV is 0, 0, this thing is negative because we're defining a radius here as well, and that's negative. So that's inside of our circle. And then we're going to, so usually you wouldn't just set the color to the distance itself. You would use this distance as a mask, as we'll see later. I'm not actually, this is actually sort of like masking it right here actually, but we'll see that in a second. So, oh wow, it's a circle. So we can see how we have positive values on the outside and negative values on the inside. And then we kind of have whatever's going on here. And we'll see that's just because we're setting it directly to, we're setting our color directly to distance, and that doesn't really make much sense because this distance value is not in a 0 to 1 range. It's like a 0 to, it's a 0 to infinity. It's not really a defined range. So we can use this step function, and we're setting the step at 0.01. So values, so basically this is essentially putting it at 0, but we'll see why we didn't put it exactly at 0. But well, later actually we will. But yeah, so this step function is going to return 0 or 1. So again, we're getting back into a defined range, and then based on our distance. So we'll see how that looks. Oh, look, now it's a perfect circle. Well, I say perfect, but it's a circle. And then you can make it look a little bit better. You'll notice this edge of the circle is a little jagged. The pixels are either white or black. There's no in between. That doesn't always look the best. So we can use smooth step. Our left edge is 0.101, and our right edge is 0.1. So it's similar, very similar to this, but instead of just cutting off right here and returning 0, 1, between these two values, we're returning a smooth value. And then we'll see, oh, it kind of blurred it. And if we increase this value on the right edge, then you'll see, so remember, we don't really want to decrease this one because I mean, we can, but it's kind of just weird to do that, I guess. But the line of our circle is when d equals 0. So yeah, then we can mess with this stuff. I encourage you guys to mess with the code. That's how you learn shaders the best, is just seeing how things change. It's very visual. for fragment shaders. All right, so that's a circle SDF, a 2D circle SDF, and our code. All right, so now I say now you try. Um, we're not gonna wait for people to try right now, but what I do want is for like after this workshop or like tomorrow or whatever, you guys go on ShaderToy or whatever your preferred way of compiling and displaying shaders is, and draw cool shaders and put them in one of the channels. Put them in the showcase channel. Yeah, maybe you can link the showcase channel in the chat. So sometime after this workshop, you guys, I want you guys to like mess with the shader code that I've given you, or find your own stuff thing you want to make and try and make it. But this is already code. Okay, so this is the challenge that I challenge you guys with. I'm gonna show you the code. I guess if you don't want to look at the code, don't look at it. But I'm gonna show you it anyways, just as a learning experience. But you can make stuff like this. So maybe like start to look at it. So one of the great coolest things about shader programming is that you can kind of take any visual, either in your mind or from a reference or whatever, and you can like piece it together in your mind of like how you would like make it. So I was like, when I was coming up for this workshop, I was like, I want a radar. I want to make a radar. So I was like, okay, well, circle, pulsating like circles going outwards, and then green. Okay, that's a radar right there. A simplified radar. It's not the best one. You could do more stuff to it, but it's the idea. So I will show you how you could try and make that. So let me, can't really make this bigger, but oh yeah, I don't think I'm using this. So actually we will remove that. Okay, so I'm gonna just walk through this code real quick. So we have our UV cord here. This is the same thing we've done in the past. All right, now here we're using our SDF. So you'll notice I don't have like any radius here. So this is not technically an SDF. This is just length from the center, since we're putting in UV here. So it's just 0 to infinity. The reason I'm doing this is because like I don't need the center. Like I don't need a defined inside. I just need like how far we are from the center. So it's like it's not really an SDF, but it's the same idea. All right, now we're actually going to mask this D value, or we're gonna use this D value and get some sort of mask from it. So we want, basically what I mean mask is we're gonna get a defined range that we can use for other stuff. So you see we're gonna pass into sign here, and we're gonna, so if you guys actually I'll pull this up in a second, but we're doing some stuff here to the thing we're passing into sign. So this value here, multiplying your input in a sign function kind of like compresses the it shortens the frequency, or well, no, increases the frequency. It shortens the span. So and then subtracting it is giving it an offset. So we're using time here, and you can see if we change this value, it gives us less rings or more. But and then time is that value is constantly changing, and that's what's moving our rings. So we can even add it to start making them come inside, or yeah, do that. So quickly, I'll show you how this is looking in Desmos. So a great thing about shaders is that it's pretty much all just math. So we can kind of see what we were doing here. So we're multiplying to our input for the sign function. You see how that's increasing the frequency, and then so it's compressing the things together, and then are we absolute valuing it? We're gonna get the absolute value next, because we don't want negative values. So the issue with shaders is that our output can basically only be from a 0 to 1 range. So we don't really ever want negative values, that I can think of, like a reason you would have negative values. So we're absolute value going to absolute value our sine function. So that's just going to give us the absolute value. Yeah. And then the next thing we're doing here, this is an interesting one. I didn't actually think of this myself. This is a pretty cool thing I saw in a video. We are basically getting the sort of the inverse of mask. We're dividing a small number by mask. And what this will do, and the reason we're choosing this small number, I'll show you in a second, it's kind of to keep us into the 0 and 1 range. But what this will do is on values closer to the center, of like the center of the, not the center of the screen, the center of the like band, it'll shoot up that value to like 1, and then it'll drastically drop off the closer you get to an input value of 1. So kind of show what's going on there. So 0 to 1, these values are, this is this mask. So maybe I should have used another variable here, but because we're just reassigning it. But this mask is a 0 to 1 range. So so you can see as we get closer to 1, as we get closer to 0, actually, our thing's shooting up. So I'll show you kind of what the difference looks like here. Well, okay, I really should do some other, there's some other transformations I should probably do before I show that, but it kind of makes the colors just pop out a lot more. Here I would have to like maybe change that a bit, and do some other stuff. But anyways, so that's yeah, that's I guess I also forgot to mention that this is also flipping our, sort of flipping like what values are 0 and what values are 1. So anyways, that's not super important, but so now we're going to smooth step things, you know, just make things look smoother, or else we get these like really weird looking lines. And then now, so okay, like let's say we just had up to that. Actually, we could just return. So, oh no, sorry, not return. Oh yeah, I guess, yeah, I think we can just return here. Okay, I guess I've been doing too much shader programming in Unity to. All right, well, anyways, so we'll just do it here. Oh, oh right, that's why. So you can see now we have the bands, but no color. So the next thing I did was I guess you can't return. So the next thing I did was I got another length from the center value, did some modifications to it to kind of like change how it looks. So we'll see here what this value looks like. So it's kind of just this like cloud. I don't know. It's just a cloud looking thing. And then we use that in a mix function. So we're interpolating from black to this green. This is a green color here, by this value. So 1 is more, 1 in the center is more green, and out here is less green, going towards black. And then we just multiplied. So remember, our mask is just, again, these 0 to 1 values right now, and we're just so we're literally just color masking right now. Like as anyways, but yeah, and then that gives us something like that. So there's a lot of other cool stuff you could do too, but that's just one little example. Yeah, so, and then here's the like code that we just had, and we'll link all this stuff like later. I'll post the shader toy things in the slides as well. Yeah. All right. So that's pretty much it. But I did want to share with you guys some other stuff. So I could add more here, but I wanted to keep it more like shader centric. But there are other resources in our Discord server. We have a channel for resources, so there might be some interesting stuff in there for you. If you guys want to learn more about shader programming, we covered some of these. This new website's really cool. It's basically leak code for shaders. It's brand new. I say brand new. It's like, it's pretty new. The developers are still working on it, but this is a really cool one. I haven't used it too much, but it is pretty cool. And then if I have any Unity developers, specifically for shader programming, because it can be kind of annoying in the engine, Catlight Coding and Freya Homer are great resources. And so yeah, we will link that form. I think yeah. So we're gonna have a form. If you guys don't mind filling it out. Um, yeah, that's you're good. That's like a form for feedback from this workshop and presentation slides. We would appreciate if you guys fill that out, so we can get better at presenting workshops. Also, so thank you for attending. I appreciate my GPK or peeps for tuning in for a virtual. This will be like a virtual series because I'm guessing that we're not going to be able to do a whole lot of in-person stuff anytime soon, but who knows. I will mention that I am hosting at least one workshop. Thank you so I'll be hosting at least one workshop for Night Hacks. So I mean, you guys probably wouldn't need to go to that, but we will be doing some stuff for them. So, anyways, maybe also doing some stuff for Game Dev Nights, collabing with them. But anyways, that's it. Yeah. So thank you guys for tuning in.
Yes. Thank you, Alex, for presenting that.
Thank you everyone
Yeah.
that came today. We really appreciate it.
And if you guys are interested, either I mean, we don't have a form right now, but if you guys want to host a workshop of your own, message me, like DM me. I'm open for DMs, unless you're a scammer. So don't be a scammer. But I'm open for DMs. If you have something that you're interested in, or you're just interested in getting involved, like with making workshops, we want more content. Um, we want more content. I don't want to be like I'm not lazy or anything, but I need some help, guys. But we want more content. We want there's a lot of people, for example, who are interested in 3D modeling. I don't know any 3D modeling, so we could do a workshop on that. There's some game devs out there that want to do some stuff. Some C++ people who want to learn C++. There's a bunch of stuff out there that people want to learn, and I can't do it all, so I need help. So if you guys are interested, DM me. DMs are open.